Thank you. Good morning, everyone. My name is Marek Aufart. I work for Red Hat. I'm based in Brno office, which is close. And this talk will be about moving legacy to cloud native, meaning applications and their transformation with Konveyor AI. First, I will briefly explain what Konveyor is about. There was talk last year, so just a quick reminder what was relevant there. And then we will continue how AI is incorporated and how can AI help with Konveyor transformation. First, let me read the Konveyor vision. The vision is to be ultimate open source toolkit to help organizations to safely migrate and modernize their applications to leverage Kubernetes and cloud-native technologies, providing differential value on each stage of the adoption process. What it actually means? That means that we want to take legacy applications. We want to take legacy applications and make them modern. More precisely, first applications need to be assessed, prioritized to help to decide what makes sense to be migrated, what doesn't, etc. Primarily, we focus on the replatforming and refactoring of the applications, so we do pretty much minimal changes in the source code to have it running in a new environment. And the focus on the Konveyor itself is to do it in the scale. Because if you have one single application, you wrote it, you most likely know what is inside and how to change it, for example, to run in containers. But in the large-scale deployments, like some bigger companies, that might have plenty of the applications, don't know actually what is inside and don't know if they can migrate it on the new infrastructure, for example, in case that the old one has been end of life. So the Konveyor project itself belongs to Cloud Native Computing Foundation. It's a community that helps people and others to modernize applications by providing open source as well as methodology how to actually use it. As already mentioned, Konveyor focuses on replatforming and refactoring of applications. And historically was originated in a wind-up tool for Java. May I ask, have anyone heard of wind-up? Oh, nice. Great, me too. So let's continue. A Konveyor application itself consists of kind of three components or three ways how to use it. First one is cloud native. There is a Kubernetes operator, which is called Konveyor. It allows to be installed on Kubernetes distribution, OpenShift, or just Minikube or this kind of minimal setup. This application serves with some UI that allows managing application portfolio. This is relevant for the first step of the migration, that the user or community can put multiple applications there, do some screening of the applications, run analysis, and decide how to migrate, what should be migrated, etc. There is also some more kind of business functionality regarding the questionnaires and other business supportive steps for the migration. Of course, internally there is also analyzer, which is the key component which analyzes the application sources and dependencies and so on. More lightweight tool is called Kantra. This is just a command line binary which contains the analyzer inside, and it's allowed to, you can download it, and you can run the analysis locally without having a Kubernetes, but also you don't have some UIs and this magical thing. What was new within last year with Kantra is that originally it used the same Kubernetes containers as were used on Kubernetes, so you just run analysis within the containers on your local machine. This has been changed because for some users it is not acceptable to just run containers. They are just allowed to run the application. So the Kantra was extended with functionality, for example, to set up language servers, check Maven, for example, for Java, and to be able to run directly on the host without any containers. Third part is focusing on IDE. Since migration itself should more likely include some part of refactoring, which means a change of source code of some application, the IDE is probably the right place where to do it. So we want to be close to that, and we also incorporating AI helpers to make this more efficient and more helpful to users. All of those three components actually contains the analyzer itself and some rule sets and other parts. But just wanted to mention that analyzer is like always there and is behind all the Konveyor installations. Now let me briefly do some overview how the UI looks like and to get some idea how Konveyor methodology is supported here. There is the application portfolio. Those applications can be added manually, but also imported with a CSV file or some API. Once those applications are there, there is some kind of auto-discovery. So the Konveyor analyzer itself takes each and every application, check what languages is it written, also what frameworks are used, and do some kind of surface information about the application itself. Those applications can be, for example, divided to some migration waves, can be connected to business service and generally to be like close to business or to organization which does the migration. Once applications are there, migration can run. So for the migration, it's necessary to tell Konveyor from what platform we want to get it to, like what the destination of the platform. Most generic is the containerization, which means that generally I have some monolith or some often Java application, and I want to run it in containers, which means that later, for example, on Kubernetes, but the main requirement here is to have just the containers and allow to run it. Currently, there are multiple languages. First, supported was the Java, and still is kind of the most used because of amount of legacy applications in the companies. But we also support .NET. Actually, the .NET is supporting both the Linux version, which I think .NET Core, or how is it called, and also the Windows. The Windows has just this advantage that you cannot run it with the UI; it has to run on Windows with our CLI tool. Other languages that are supported are Golang, TypeScript, Python, and this is currently an effort which is adding more and more languages, since the analyzer is written in pretty modular way, so it can have multiple providers for different languages. I said we have analyzers with some languages, and then the analyzer needs to know what to find in the applications that needs to be fixed or updated in order to be modernized. So let's say the rule set or rules, how to tell to analyzer that something is wrong within the application and the way how it needs to be fixed, it's within the rules. These rules are somewhat similar to what was originally in windup. There was in XML, this is in YAML, but also there are some, let's say, other small differences. Generally, there is always some when block, which can describe some expression how to find some issue within the application. It can be as easy as some kind of regex or something like that, but it also can ask some language-specific methods. For example, this is some referencing some Java class. Also, there could be some inheritance, constructor calls, and so on. So these tools can just really understand the language-specific stuff. Also, can check the dependencies, for example. Next, once this block has when block found some issue, it should also contain information like what to do about it. So once the issue is discovered, then in the UI or some output, it should be shown that, hey, we know this issue is problematic, and here is how to fix it. This human readable originally was meant to some consultants, so they have idea how to work with this issue and how to fix it. To get overall information like what is how severe the issue is, there is some effort. This is just really a raw estimation that hey, this is no issue, you can fix it in that way, and it will not take you that much time, or it will take you a longer time. That depends on the effort. So we have analyzer and also the rule sets, and now let me briefly describe on this diagram how Konveyor analysis actually works. We have rule sets which are originally provided out of the box. There is over 2,400 rules which are just on the GitHub. You can use it. It primarily focuses on Java, but also there are some different languages. Of course, you can use your custom rules within your organization, because as a migration process, the organization might find that they have some internal frameworks or something which is not that common, so we don't have it in Konveyor repository. And then might write new rules with the YAML from previous slide to just make Konveyor understanding it and providing information how to fix it. They might provide it back to Konveyor, they will be happy, but it's not required, just they might create those rules too for internal use. Actually, analyzer's engine takes those rules and starts querying the application. As I said, the analyzer is pretty modular, so there is something between the application itself, it can be source code or binaries, and the analysis. The something is LSP, there is language server protocol originally written by Microsoft, which allows some unified querying of the source code of the applications. And the analyzer here just evaluates each rule, and in the end, we get some report. The report is basically a list of violations, what is wrong with the code, and what is needed to be fixed. The example, how it could look like in the UI, or it might be small, but we have we have some file which is wrong, or there is something wrong within the file. You can see the source code line, and also some information how to proceed or what to do about this issue, and some links potentially. This is also just one incident in one file, there can be multiple, and here you can see that you have, for this given application, currently I can afford 2, so there are just 2 small incidents. But generally, if you put it back to application portfolio, you will be able to see that there is applications which are kind of easy to migrate because of low effort, as well as applications which are more hard to migrate. So it accordingly can be planned, or the migration step would make sense to migrate first, migrate later, etc. Konveyor focus on the scale. So this was an example of one application. But let me remind how that works. So we have some application source code, run analysis using the rules, have some issues. Those issues should be planned according to a complexity or what kind of issues there are. Then there comes someone who is called migrator, generally some consultant or someone who will take the application itself, source code, open IDE, do fixes. During the fixes, he might find that something was missing there, so there is still something broken, but we don't have it in the rules. So in that case, this issue should be raised, and allows to create rules which will cover these unknown or so far unknown issues. This is once this is added to rules, in the next iteration we know that there is something wrong, or there was something wrong, but we know now how to fix it. And this loop takes pretty much of iterations, really can take a long time. Now there is some migrator, which is the human. We of course like humans, but doing one thing once and again and again and again, it's not that fun, and also it has quite low efficiency. So there is AI. So why not to tell the AI to, hey, help me with these migrations or with these source code changes? That's something which Konveyor AI, or shortly KAI, wants to focus on. So the goal was to improve economics of the replatforming and refactoring applications to Kubernetes by leveraging generative AI. The approach that we currently take is to expand Konveyor capabilities beyond surfacing, which means we are reporting the issues and just saying that this is wrong, this is how to fix it, and build OpenRevWrite. OpenRevWrite was integrated in the Contra CLI and is a kind of basic tool which can describe you some code transformation, that if there is some pattern in the code, you want to change it. But this is not that smart, and it's pretty limited. So, on top of the reporting issues, KAI wants to generate suggestions for the code changes, and want to work with LLM to get those changes somehow alive and working. There was a question how to use AI generally, because there are plenty of chatbots, but also there are models behind. So it was theoretically a chance to have a model, and you should be able to train model for your application, your frameworks, and to run it. This is not like that economic. It takes a lot of time, a lot of effort, a lot of computing power, and it's very specific to would be very specific to applications and framework within the company. So we took a little bit different approach. The approach is called RAG, Retrieve Augmented Generation, which means that we have like very general LLM. It could be some online or locally installed, it doesn't matter, but it's just generative AI, which has not special training, it's not fine-tuning, but we pass it as context, important information about the source code and about the analysis issues itself. So we don't train the model, but we do pass all relevant information as the context to the model or to the queries to the model. This is one of the advantages, and the advantage is it's is modern agnostic. Since it doesn't bring any model with it, it just allows you to use some third-party models, which can be ChatGPT online or can be Ollama installed on your laptop. This is also like quite nicely working. And also it allows some limitations in companies that might be restricted to not upload data outside of the company, but they might have some allowed AI services to run this. So how actually Konveyor AI wants to do it? So it generates code suggestions. Primarily we started with Java. As mentioned, there is plenty of legacy code written in Java, so this is our main focus. And based on the rules, we want to create new changes of the code which address those issues. There might be multiple iterations of these changes, so it was quite sane to use some changelog of history. So if LLM suggests some change, we want to store it, maybe later evaluate. This all is passed to LLM, already mentioned, and with all context or parts of the application source code. Just for information, most often it is not possible to upload all source code of the application to LLM as context because it's usually like too large. So Konveyor does some kind of heuristic based on the rules, what files need to be uploaded to LLM to just decide what might be changed and then does iteration on top of it. While LLM can easily provide you something which will look like a source code, which might look nice, it often doesn't work or will not work for many reasons. It might have like too small context or some misunderstanding. So we have to use agentic workflows, which means that locally in the IDE on the background, LLM will need to check, for example, some linters, try to compile, try to build, maybe try tests, just to ensure that the suggested code changes from the AI is somehow relevant, because often it might not be that much relevant. And since this is all related to change of the source code, we implemented it as IDE plugin. In our case, it was VS Code, or it is VS Code. This is probably the biggest diagram I have for today. Let's start. This is Konveyor. So we have legacy source code, Konveyor itself, some analysis, and code issues, which were described in the first part of this presentation. There is an LLM prompt, which is populated with the issues as well as some parts of the source code of the application, and is always passed to LLM. This is general chat, question, query, nothing really special. LLM will try to maybe guess some change which needs to be done, but we using an MCP protocol, we have some agents. So these changes might not be that correct, so just before it's displayed to IDE, first there are a few iterations of LLM to get somehow happy or agree at least with the changes that it's not like totally insane, but it's somehow relevant and somehow doesn't break the code application itself. Once LLM is somehow happy with the change, it's displayed in the UI. So the migrator, the human, can take a look and make a decision if this is something solution that be accepted, or there are some manual changes needed, which is also often relevant and often important. But also there are some suggestions about reasoning from LLM, like what it thinks that it's wrong and how to fix it. So the change itself is usually on the humans, just to accept or reject or update. Once there is some approved solution, that needs to update the source code. This is just one part. But Konveyor AI wants to learn and do some incremental being better. So if there is one solution, we also put it to something which is called solution server, which is within the Konveyor itself, within the IDE. And there are data which maps actually the issues which that should be solved with the final code set of code changes that have been applied to the source code and has been accepted as the solution. So this just doesn't include only LLM suggestions, but also include the changes from what human or a migrating person did manually in the source code. In the next queries, this is also passed to the prompt as the context. So the next suggestion from the LLM or next response might be more relevant and might somehow kind of learn from the previous accepted solutions. This should generally bring much more efficiency and much more power to that process. Now let me speak a little bit about the prompt itself. So we have some prompt instructions which are embedded within the conveyor, basically saying, hey, I have this program, these issues, and there is context with the source code, some structured data with the issues, etc. By default, you just send to LLM and you get some source code in the result. This other part is the experience from previous steps and accepted solutions. So the AI will be, or LLM will be provided with a set of patches which are connected to the already solved issues, if it's the similar issue that already has been solved. Once from the prompt there was a response from LLM. I mentioned there are some agentic workflows with multiple loops that should decide if LLM is happy with the result and the result is not breaking the application. So in the first part you can just see that we check if the issue has been already solved and has accepted solutions. If not, it's just the code what goes to LLM. If yes, there is the relevant code snippet with the patches from the previous slide. But now let me focus on this LLM result and the agentic workflow. The workflow has really many steps. It could be attempts to compile, check some linters, but also we do need to call Konveyor analyzer again, because LLM actually he provides some suggested changes how to fix it, but doesn't know, for example, if the issue was solved. So we need to call analyzer again and to tell that, hey, AI, your change is fixing the issue or doesn't fix issue, and other stuff on this part. So this actually may take some time, some iterations, which are just being done under the hood of the solving issues within the IDE. Those agentic workflows are very relevant and important to have some refined result, because it might be usually not that clear what comes from the LLM. So it's really plenty of iterations on the first LLM response. For example, code may want to compile, as well as check analyzer if there is issue has been solved or not yet, and also, for example, dependencies. And this is really a long process. It doesn't mean that there is someone like a human waiting for it, but this is just a step when Konveyor is asked to solve some issue within the VS Code ID. So this is what happens under the hood. And the main purpose of these agentic workflows is to ensuring that the code is usable and is still working, because this is quite easy to break the application. That was for theory, and now I have a few slides which can give you some idea how Kai actually looks within the VS Code. So it can be installed as a VS Code plugin by default, or you can, if you would try, there are some steps how to set up it quickly with some README. Generally, it's first need to configure access to some AI LLM model service. It can be some OpenAI or, for example, some granite model running on OpenShift AI, as well as locally Llama running Llama 4 model or something. So it can also support like locally running models on your machine. That might be that much smart, but still somehow better. You can see that then Kai server will start to run, and within a chosen application, you will run the analysis. Analysis, it's a similar way as the UI shows some issues. So we have some file which contains this is still same type of issue. This is a general list of all issues. And this group there, this is a Konveyor solution, that is the list of accepted solutions. This is the first one, so we have nothing there. we want to ask Konveyor to guide to do some fixes, suggest a new solution. There might be some reasoning, and we're already starting to populating some resolution which is in progress currently. In the end, we will be able to see some patch. This patch is pretty minimal. There is just some import change, and user can or migrator can accept or decline the solution. Of course, there can be non-trivial changes like this, and in the end, all issues might be accepted. You can see that will succeed. There are some already known resolutions. And these were just a few slides. It's not like complete workflow, but if you are interested, please take a look at this scenario. This was an example of Java EE to Quarkus migration with Konveyor AI. This is QR code for that. And we are getting to the end. I would like to, if you are interested, please feel free to try Konveyor. It can be installed with extension to VS Code. Extension is pretty big. I'm not sure if it's already within the marketplace on the VS Code, but you might download it directly from the GitHub. In the March, a few months back, we have 0.1 release. It's already working. We are working on that more to really make it helpful and smooth, hopefully. Also, we provided some getting started scenarios, which contains many steps, some screencasts, how to use it. Now we are coming to conclusion. So on this QR code, you find links from this presentation if you're interested on Konveyor itself, as well as some getting started guide and examples how to use it. Our source code is open. We are everything hosted on GitHub. We are open community. If you are interested, please join us. For example, Konveyor channel at Kubernetes Slack. I think that's it, and I'm ready to your question.